Howdy, and welcome to a video on factoring and long division. Um, I will be covering factoring in long division of polynomials, as the title suggests. The problems I am working on are from the Virtual Math Learning Center. I will post a link to these problems in the description. Alright, so let's start with the first problem, right? And we're factoring this polynomial right here. Now, if you notice, although we have two of these exponents, right, we can simplify it a bit, or rewrite, so that we have 4xy squared minus 12xy plus 9. It looks like a quadratic, so I'm going to use a little substitution. So I'm going to make a variable, I'm going to put z, and I'll make it equal to xy. So z squared is just xy squared, right? After substitution, generally use pink. Oh. Let me use a different color. So z and z squared. So we can rewrite this as 4z squared minus 12z plus 9. Okay. And from here, we can use the butterfly method. I'm looking for two numbers that multiply up to 36 and add up to negative 12. Okay. I believe, actually can't think right now. It's 9, 4, just write out numbers. 136, 218, 312, 4, 9. Oh, 6 and 6, right? So negative 6 and negative 6. So we get 4z squared minus 6z minus 6z plus 9. We can take out a 2z from the left side, and we get 2z minus 3. And we can take out a 3 from the left side, a negative 3 rather, and we get 2z minus 3 left over. Common factor, group that out, and then we add the rest. These are the same factors. So you can write 2z minus 3 squared, sorry. But then we have this z still here, right? We need to make sure that we put in our original variables back. So we get 2xy minus 3 squared. And that is my first answer. So for number 2, I need, so it's a quadratic, right? It's a second-degree polynomial. So very straightforward. I need two numbers that multiply up to negative 10 and that add up to negative 3. This is a negative 5, positive 2. I don't know why I wrote this so big. Oh well. 10y squared minus 5y plus 2y minus 1. We can take out 5y here to get 2y minus 1. And we're going to do a plus 1. 2y minus 1. And common factor, take that out. And then add the rest. So 5y plus 1. And that is your answer. Okay. For number 3, right? You might look at these and like, oh, you FOIL this for that. But if you look carefully, we have a common factor here, a common factor here. So the first step is actually to group. So we take out the x minus 1, right? And then we add the rest, okay? So x squared plus 3 plus x squared minus 5. So that is x minus 1 2x squared, right? Combine these together. And then combine it plus 3, negative 5, so it's minus 2. Now, from this one, right, we can factor it out a little more. Of x minus 1 times 2, x squared minus 1. I'm going to bring this out. I'm going to bring this out to the front this way, so I have some space, okay? So 2x minus 1, x squared minus 1. But from here, you can see this is difference of squares. Okay. So we can factor this out even more. 2x minus 1. I'll write in purple so you can see. X minus 1, x plus 1. These are the same factors, so we can combine them. That is, sorry. X minus 1 squared, x plus 1. And that is our answer for number 3. Okay. For number 4, again, we have a nice quadratic secondary polynomial. So we can just straight up factor using the good old butterfly method. Two numbers that multiply up to negative 18, but add up to positive 17. That is 18 and negative 1. So negative 6z squared. Let's do minus 18z. And plus, sorry. And minus z plus 3. Okay. Take out, what do I want to do here? Take out a positive 6z. Okay. And we end up with negative z plus 18. Well, not 18, 3, right? We take out a 1, and we have a negative z plus 3. Common factor, let's take it out. So negative z plus 3. And then add the rest, 6z plus 1. I usually don't like this negative sign in the front, so I like switching these two. This could be your final answer right here, but out of personal preference, I prefer 3 plus z, or 3 minus z. 6z plus 1. It doesn't really matter which one you do, but some prefer it first because the z's are in front. I like the second one because I don't like negatives in the front. Okay, so that is question 4. Okay, and now we need to find the quotient with remainder if necessary. Okay, so with long division, it's just like integer or decimal long division. So we're going to write out the full equation. And note that if I'm missing any, like when I go down and write, right, I should see all of the powers ascending. So 3, 2, 1, 0, I'm good. But if let's pretend this was missing, right? And like this was the original equation. And I noticed that this is missing, right? I'll put in a 0x just so that the spacing is correct. Okay. But all the powers are descending one by one, so nothing to worry about here. And now divide that by x squared plus 1. So first we can see we're gonna check the x squared, right, against the highest power. So we have this 2x cubed right here. One moment. Right. So if we look at the 2x cubed divided by x squared, right, we would get 2x. So it goes right here. 2x, and then we multiply 2x by the divisor, and we get 2x cubed plus 2x, right? And all of that will be subtracted. So we get the negative x squared plus x, and then we draw down a negative 9. Now we look from this x squared to this negative 8x squared. Negative 8x squared over x squared is just negative 8. And now we multiply that negative 8 by the divisor. We get negative 8x squared minus 9, right? But we were subtracting the whole thing. That means this is 0. Oh, we get just the x. And, oh wait, that should be 8, not 9, so I'm multiplying. And I'll have a negative 1 remaining. It's 9 minus negative 8 is negative 9 plus 8 is negative 1. Now, this power is too big, right? So this is my remainder. Remainder x minus 1. So how do we write this as a fractional remainder? So we have 2x minus 8, which is our main, quotient, and then x minus 1 over x squared plus 1, right? Because we have this left over, right? So in reality, it's just this left over divided by this, and we didn't really bother to divide it. Because like I said, right, when we did the Brown step, I tried to do x minus 1 over x squared plus 1, but that's not going to work out very well for us, right? So this is my final answer. So note that the divisor cannot be factored. It's not x minus 1, x plus 1, right? Because it's not a difference of squares. This is a sum of squares. There's no rule for that. So yeah, that is it for question 5. And this concludes my factoring and long division video.